All right, so we're going to take a look at number 7 in the team round for 2015 state competition. This is actually a really cool problem. I kind of really get into these geometry problems. I think they're neat. So here we go. I'm going to give myself a little room because I need a drawing here. Sorry. All right, so we know that we are getting a hexagon, and we know a hexagon has 6 sides, and we know it's equiangular, so it has 6 equal angles, and so each angle has to be 120, and that's going to be really important to us. And we also know 4 of the lengths, and we need to figure out the difference between the other 2 lengths, and we can actually find those other 2 lengths too. And so I'm going to go ahead and draw this. So 4 units, and then we have 16 units, and clearly I'm working backwards here. Why? I don't know, just happened that way. So we know this is 9, and then that has to be 1, which leaves 2 more side lengths that they're clearly not going to be to scale, so please forgive me on that one. And so here we have our hexagon. And I'm going to call the angles, or the vertexes of the hexagon A, B, C, D, E, and F. And then I'm going to create a rectangle, because rectangles are much easier to find the area of than, oops, well, that side's here, right? They're much easier to find the area of than the hexagon. And I'm going to call these W, X, Y, and Z. And for my missing side lengths, let's call this K, which is the best letter in the alphabet, we all know, and J. All right, and to make life a little bit easier, let's start looking at the angles. Well, I know these are all right angles, and I know this is 120, which makes this 60, which makes this, oh, check it out, 30 degrees. It's a 30-60 right triangle. No way! This is also a 30, because this is 120, and that makes this 60. I have a whole bunch of 30-60 right triangles. Well, 60, so here's 120, which makes this 60. Now this is when my crappy drawing gets in the way, which makes this 30. This side is bigger than this side, despite my bad drawing, I'm sorry. Which means this is also 30, and this is 60. Okay. And just to remind you, when we have a 30-60 right triangle, we know this side length is A, which means this side length here would be 2A, and this side length is A times the square root of 3. So if I want to go from this side length to this side length, I have to divide by the square root of 3. All right, so let's fill in what I know. So my smallest side length for this triangle is right here. My longest one is 16, so that makes this 8, which makes this 8 times the square root of 3. That's not too bad. My smallest one is here. Half of 9 is 4.5, which makes this 4.5 times the square root of 3. These are going to be really helpful because I know that this side length is going to equal this side length here. And vice versa, this is going to equal this. All right. So then, over here, since this is K and my smaller side length is here, this is going to be K divided by 2, which makes this K divided by 2 times the square root of 3. Using the same logic, my small side length is here, which makes this J over 2, and this is J over 2 times the square root of 3. And so now I have K's and J's, and so I can find what K and J are, although I don't necessarily have to in this problem, because I can write equations. I know that this side length has to equal this side length. All right, so let's go ahead. We know that K over 2 plus 1, because that's 1, plus 4.5 must equal j over 2 plus 4 plus 8. Let's simplify this. So I have k over 2 plus 5.5 is equal to j over 2 plus 12. I don't particularly love having the divided by 2, so I'm going to multiply everything by 2 to get rid of my fractions. And so I get k plus 11 is equal to j plus 24. Throw over here, Eric. So, okay, well, let's read the question. The question is asking, what is the absolute difference? Oh, I want a difference in the length of the two remaining sides. So my difference in this case is going to be k minus j. Can I get k minus j out of this equation? You know what? I can. So let's subtract j from both sides. So I get k minus j plus 11 is equal to 24. Subtract 11, and I get k minus j is equal to 13. And there's my answer. Now, did you know that I can actually find out what k and j are by making a system of equations? I can set this side equal to this side, and I would get k plus j is equal to 25, and then I can use my systems of equations to figure out that this side is 6, and 13 plus 6 is 19, and so great. Isn't that exciting? Okay, cool. All right, next problem. All right, so let's take a look at number 8. And I'm not going to lie to you, I struggled a little bit with this convex sequence. It's not something that I've seen before, so it took me a while to understand what it meant. A convex sequence is a sequence of integers where each term, other than the first and last, is no greater than the average of the terms immediately before and after it. So in other words, I'm going to take the value of the term to the left and to the right, I'm going to average them, and so the term in the middle has to be that average or less. That's how it goes. So the reason why the first and last number don't matter is because there's no number preceding the first number, there's no number after the last number, so you can't have an average there. It just doesn't make sense. So I have to have my 7 and 8 there for the most part, but we'll get to that. And so I'm only allowed to use these numbers. So clearly this is a convex sequence because the average of 6 and 8 is 7, the average of 1 and 3 is 2. So this works. So we know that 1, 2, 3, 4, 5, 6, 7, 8 is going to work. And since that's going to work, the opposite is also going to work. 8, 7, 6, 5, 4, 3, 2, and 1. Because the averages, it doesn't matter whether it's over here, the average of 8 and 6 is always going to be 7. So then I need to come up with some other ones. And I know that this sequencing is going to be important. And so I can also go with 7, 1, 2, 3, 4, 5, 6, 8. I mean, that's going to work because the average of 7 and 2 is bigger than 1, and same thing over here. 6 is less than the average of 8 and 5. And so I can flip the 8 and the 7 again. 1, 2, 3, 4, 5, 6, 7, and so now I have 4. Well, following that logic, I can do the same thing, but reverse the interior of this series. So I can have 7, 6, 5, 4, 3, 2, 1, and 8, and I can have 8, 6, 5, 4, 3, 2, 1, 7. And so right now, I have 6 series, and if I'm being an honest man, I would say that that's probably where I would stop. But this is a state round, and in the state round, they always like to have a little bit of a curveball. I also know, and here's the curveball, I also know that the average of sequential odd numbers and the average of the sequential even numbers will also end up giving me a convex series. It will. So I could go 7, 5, not 4 because that's not odd, 3, 1, 2, and now I'm going back up, 2, 4, 6, 8. The average of 7 and 3 is 5. The average of 2 and 3 is greater than 1. The average of 1 and 4 is greater than 2, so I'm in good shape. And then I can reverse that series. I could go 8, 6, 4, 2, 1, 3, 5, 7, and this will also work. And so there are my additional 2 series for a grand total of 8. That's why I do this, because my 8s don't look good when I don't.